Okay, good morning. We're going to do some more solving systems of equations, only this time we're going to do it by a technique called substitution. So I'm going to substitute one equation into another. Now, to do that, I need one of the two variables, it doesn't matter whether it's x or y, to be isolated or on a side by itself ready to go. So I have y equals x plus 9. Y is isolated all by itself on one side. And then I have 3x plus 8y equals a negative 5. I know y equals x plus 9. So what I'm going to do is I'm going to say, since I know y equals x plus 9, I'm going to substitute that in for y on the second equation. So I'm going to take all of this and substitute it in for y. Let's try it. I get 3x plus 8 times, now I'm going to take all of this and substitute it in for y. X plus 9, then I will go back and finish the equation, equals a negative 5. Now I will solve. 3x plus, I will distribute 8 times x, then 8 times 9. 8x plus 72 equals a negative 5. 3x plus 8x is 11x plus 72 equals a negative 5. I will subtract 72 from both sides and get 11x equals a negative 77. Now I want to solve for x, so I will divide both sides by 11. I'll get x equals a negative 7. X equals a negative 7. So I'm good there. All right? Now I take that negative 7 and I substitute it into one of these two original equations to solve for y. And I'm going to always pick the easiest one, so I'm going to pick y equals x plus 9. So y equals x plus 9. Well, what is my x now? Y equals a negative 7 plus 9. Y equals a negative 7 plus 9 is 2. There I have my solution. The solution is negative 7 and 2. Okay? I do my check steps. So that's my solution for the system of equations. I do my check steps. All right? I will say 2 equals a negative 7 plus 9. That's my first equation. 2 equals 2. Check. I will take my second equation, which is 3x, or 3 times a negative 7, that's my x, plus 8 times my y, which is now 2, equals a negative 5. 3 times negative 7 is negative 21, plus 8 times 2 is 16, equals negative 5. Negative 5 equals negative 5. And check. Good to go. Woohoo. All right. Let's do it again. I've got my two equations. 2x plus a negative 3y equals 11. and 2x plus y equals 9. Well, and neither of these have a variable that is isolated on a side by itself. So I'm going to do a little work, and I'm going to pick this equation because the y, it already doesn't have a coefficient, of course, other than 1, but that's cool. The assumed 1 is not a problem. So I'm going to take this equation and solve for y. So I'm going to subtract 2x from both sides, and I'm going to get y equals a negative 2x plus 9. Y equals a negative 2x plus 9. Now I have y by itself, isolated with no coefficients, equals all of this. So I'm going to take all of that. I can't use this equation because that's these are the same equations. If you can see, I just adjusted them. Okay, these two are the same. So I'm going to take all that and I'm going to substitute it in for y right here. Let's go ahead and try and write that out. Okay, I get 2x plus a negative 3 times all of this, a negative 2x plus 9 equals a negative 11. So there's my first equation. When I got to y, I substituted this in for y, and now I'll solve. 2x plus, now I'm about to distribute the negative 3 to the negative 2x and the negative 3 to the 9. Negative times a negative is a positive 6x. A negative times a positive is plus a negative 27 equals a negative 11. I will join my like terms. I will get 2x plus 6x is 8x plus a negative 27 equals a negative 11. I need to get variables on one side by themselves, so I'm going to move my number to the other side. If it's a negative 27, I'm going to do the opposite with a positive 27. 8x equals 16. Now some of you like to say 8x minus 27 plus 27 equals a negative 11 plus 27. You can do that. Doesn't matter. Right? Let me solve for x by dividing both sides by 8, and I get x equals 2. I'm good to go. Now I can take that and substitute it back in for one of my equations. And I'm going to substitute it in for this one right here. Okay? 2 times my new x, which is 2, plus y equals 9. 2 times 2 is 4, plus y equals 9. Subtract 4 from both sides. I get y equals 5. Y equals 5. So now I've got my ordered pair, which is going to be 2, 5. That is my answer, my solution to this system of equations. And I will do my check steps. Here we go. 2 times x, which is 2, plus a negative 3 times 5, which is my y, equals a negative 11. 2 times 2 is 4, plus a negative 3 times 5 is a negative 15, equals a negative 11. A negative 11 equals a negative 11. And check. That's one. Let me take my second equation, which was 2x, which is 2, plus y, which is 5, equals 9. 2 times 2 is 4 plus 5 equals 9. 9 equals 9. And check. All right? One more. Okay, now I look at these two equations. 3x minus y equals 3, or y equals 4x minus 8. Well, I've got y isolated and by itself, so that's good. So I can substitute all of this. Substitution, that's what we're doing, substituting in for y, because y equals 4x minus 8, so that's what y is going to equal in our system of equations. Now you can only do this with systems, and we're saying this is a system of equations, so I'm going to take all this and substitute it in for here. All right? I get 3x minus parentheses 4x minus 8 equals 3. Now, here's where it gets tricky. This minus sign is going to affect everything in here. So let me put a 1 in there, because remember, it's really assumed to be a 1. That'll help me distribute, okay? Remember, when there's nothing there, a 1 is the identity property. It's like multiplying times what you have exactly here, the identity here. So I'm allowed to put that 1 in, and it'll help me distribute so that I don't just say 3x minus 4x minus 8. That negative has got to distribute here and here. Okay? So I get 3x minus 4x. A negative 1 times a negative 8 is a positive 8 equals 3. So you can see why it's always important to put your substituted value, this 4x minus 8, inside parentheses so it can be affected by everything that the y is. Now remember, technically this would be like saying plus a negative y. So that y was negative, so we've got to make sure we accommodate that. All right? 3x minus 4x is a negative 1x plus 8 equals 3. I'm going to subtract 8 from both sides. You guys, some of you like to do it this way. 1x plus 8 minus 8 equals 3 minus 8. Doesn't matter which way you do it. If you like to do it horizontally this way or vertically this way, it doesn't matter. Just so you're subtracting 8 from both sides. I get a negative 1x equals a negative 5. I'm solving for x, not negative x, so I have to divide both sides by a negative 1. And I get x equals 5. And there is my first value. Now, I'm going to take that and I'm going to substitute it back in for one of these equations. I'm going to pick my easiest one. Y equals 4, and what's x? 5 minus 8. Okay? I get y equals 4 times 5 is 20, minus 8. Y equals 12. So I have 5. I have 12. I write my ordered pair as 5, 12. I do a check step. I'll take my first equation, and you should write those down. There's my first equation, 3x. So 3 times 5 plus a negative y equals 3. Don't lose your negatives. 3 times 5 is 15 plus a negative 12 equals 3. 3 equals 3, and check. Remember, that's the solution to my systems of equations. And my next one is y is 12 equals 4 times my x, which is 5, minus 8. 12 equals 20 minus 8. 12 equals 12. And check. So don't forget your check steps. Remember, solving by substitution. Quick review. I'm going to substitute all of that into this y. How can I do that? Because y equals a negative 2x plus 9. So I can substitute all of this, because this is what y equals, in for y. Y equals x plus 9. I'm going to say, I know y equals all of this. I'm going to take all of this and I'm going to substitute it in for y. 4x minus 8 is what y equals. So I'm going to take all this and substitute it in for y. Not missing that negative. I'm going to make sure I distribute the negative out. Once I've done that, I solve for x. Once I've solved for x, I substitute that into one of the equations, solve for y, and get my ordered pair and do check steps. Good luck today, guys.